All right, systems of equations. So, 3 different methods to solve systems. First one, graphing. Okay, we've got to find where they intersect. We have to make sure we put them in y equals mx plus b format. Okay? Substitution. We have to isolate the easiest variable in one equation and substitute into the other equation. We still have to solve for both variables. That's our whole idea behind this. Elimination. Next one, or the last one. We have to make the coefficients of one variable the additive inverse. Wow, that's a lot. Right? That means the same number different times. Then we combine both equations to eliminate, and we solve. The idea behind all of these systems, okay, is to find an x, y, and that's our solution. So let's take this system right here. Okay, we changed it. That 1/2 x plus 2 equal, and the other one is y equals x minus 1. So when I take it, I have to graph that first equation. What's the slope and what's the y-intercept of the first equation? You've got it. That. Just the 1/2.
Oh,
Remember, it's just the number. And then what's the y-intercept? 2. So let's graph that. Where do we begin? On 2, right? Right? On the y-axis, it's the y-intercept. Then what do I do? Up 1 in which direction 2?
right.
Do I go right or do I go left?
Right.
It's positive. Okay? So up 1, right 2. I'm going to make a few of those. And then right now you guys don't have a straight edge in front of you, but grab something that you can draw a nice straight line in. Because we're going to have to see where these intersect, so we want to be as exact as possible.
What's to continue the line on line?
Yeah, it's always good to continue that. And then let's label it. And let's do the same thing with the other one. So what's the slope and the y-intercept for that second one? Justin?
1/1.
Yeah. And what's the y-intercept? The y-intercept is -1. Okay, so where do we begin? -1. On the what axis? The y-axis. And then I go up 1 and
Left.
it's positive, so I go up 1, right 1. And I want to keep doing that until I run into that other line. Because where the 2 lines intersect is going to be my solution. And make sure you label it. And then what's the solution? What is that point right there? 6, 5. Yep, that's the answer. That's your final answer. Okay, that's the solution for that system. The x is 6, the y is 5. So now let's take this same system, but let's solve it by substitution. So we know what the answer is, so when we get done with this, we better end up with 6, 5. So if I were to take this same solution and solve it by substitution, do you see that y is equal to 1/2 x plus 2, and y is also equal to x minus 1? So what can I do by substitution? Yeah, tell me what to write, Sophia.
So, what's the
Yeah. She says, can you make the equations equal each other? Yeah. Because y is equal to y, so you're essentially taking that and putting it in place of that. Now I can solve this equation. It's just a two-step equation, solve for x. What should I do first? What do you want to do? Okay, we can subtract 2. Okay, a couple different steps you could do that's still going to get us to the same point. 1 half x equals x minus 3. So if I did that, now I got to do what with the x? I got to subtract the x, subtract the 1x. So I get negative 1 half x equals negative 3. And use your calculator, get x by itself. You could divide by negative 1 half, you could multiply by negative 2 over 1, it doesn't matter. What do we got? Yeah. Nope, we're dividing. No, not negative because they're both negative, so it's positive 6. So I've got the x, what do I need to find? The y. So take that value that we just found and plug it back into one of the original equations. Which one looks probably easier, the first equation or the second one? That second one's pretty simple. Right? So we'd say y is equal to, we just found out what x is, 6 minus 1, so now what's y? 5. Did we get the same solution as we did when we grabbed it? Yep, we should. Okay? 6, 5. Alright, now let's take and practice the method of elimination with the same system. We know what the answer should be, right? So we better get that. So I'm just going to rewrite the system here. So what was it? It was 1 half x plus 2 and y equals x minus 1. That was the system, right?
Yes.
Okay. So to solve it by elimination, this is what we got to do. We got to get the x's to line up, the y's to line up, and the equal signs to line up. Okay. So our two equations, we need them to look like that. So right now, we've got them both solved for y. So if I want to get the x's, the y's, and the equal signs, that first equation, what should I do with that 1 half x? I need to move it over to the other side. In order to move it, what am I going to have to do? Yeah, subtract it. So it's going to be negative 1 half x plus y equals 2. So now I got x's, y's, equal signs. What do I do with the second equation to get it into that form? So I got to take that x and move it over. What's it going to be? Subtract it, so it's going to be negative x plus y equals negative 1. Now it's in the form to do elimination. What do you want to eliminate? The x's or the y's? Which one might be easier? Y. Remember, we want to get opposites over each other. So right now I have a plus 1 and a plus 1. Well, what's the opposite of positive 1? Negative 1. So I'm going to pick one of those equations and I'm going to multiply it by negative 1. That will give us opposites. Does it matter? I don't know. Sure, let's do that one. Multiply that top equation by negative 1. The whole equation in parentheses, the big distributing problem. So negative 1 times negative 1 half gives me positive 1 half. So 1 half x. Negative 1 times positive y is negative y. And negative 1 times positive 2 is negative 2. Sorry, that's squeezed in there. And leave the other one just the way you see it. Negative x plus y equals negative 1. Now let's combine them. What happens to the y? That's what we wanted, right? That's why it's elimination. So what is 1 half x? Now just combine like terms. What is 1 half x minus 1x? 1 half x.
Negative 1 half x.
Negative 1 half x. equals, and this was a -2 over here, -2 and -1 is, oh, combining, remember, -3. Solve for x. What do we get? I bet you get 1/2. 2. What do we get? 6. How do I get the y? Yeah, go back into one of the simpler equations, and it's that second one again. Okay, y is equal to 6 minus 1, so y is equal to 5. And my solution, 6, 5. All right. Let's talk about some special cases, and we'll be done. One unique solution. It says when the lines intersect, the slopes will be different. Okay? When the lines intersect, the slope will be different. So I could write anything. What's the slope of that first equation? The slope, 1. 1 over 1. What's the slope of the second equation? -1 over 1. The lines will intersect. The slopes will be different. The slopes are different. This will give me one solution. What about the situation of no solution? What are the equations going to look like when it's no solution? When the lines are parallel. Same slopes, different y-intercepts. Can someone, I'll give you the first one. If I said the first one is y equals 2x minus 8, somebody write an equation for me that has the same slope but a different y-intercept. Sophia. Sure. Same slopes, different y-intercept. That's going to be no solution. You can draw that. A 0 with a slash through it, that means no solution. You can write out the words no solution. Infinite solutions. The last special case. Infinite solutions. What do the equations look like? It says when the lines are the same slopes, same y-intercept. Somebody give me one. Sure. What's the other one going to be? You got it. Examples of special cases. How many solutions? Consider the equation. How many solutions for the original equation? Yeah, I think we're good. We're good.